So this is my AudioEngine Milestone 2 series of demos. So I'm going to quickly go over everything because I have tried to record this multiple times and it got too lengthy. So I start out by essentially creating all of the data managers, and I am loading all of these file wave buffers up front. And basically these just get passed to the AudioEngine in the audio's in queue, and that is going to be passed as a file loading command. So we just pass the file name and then the sound ID, which is sort of the unique identifier we're giving to each sound. And I'm essentially setting these one per buffer, and then everything can kind of use it from there. And I am not loading Beethoven at this point. That will be important later on, but basically this is going to then spin off the audio thread. So once this main audio thread is spawned, it's going to spawn the file loading thread, which is going to be another thread that's just going to asynchronously load these files, and that's just going to continuously update its own queue. And if we go up here, it's just going to load any files that were given to it until this thread is essentially killed, and then the thread will die. But so this is going to spawn the file thread that's going to load the files, and then the AudioEngine itself is just going to keep updating in its own loop, where it's basically just going to check if its queue is empty and keep popping off these commands and executing them. So if we go back to here, I'm going to actually explain these demos one by one and then play them, and then explain the next one and play it, because otherwise it gets a little confusing if I'm explaining a demo and then I start explaining the next one and you haven't heard the first one, and then you have to go back and try and remember exactly what I said for each of them. So this first demo, we're creating these sounds, and the sound is basically taking in an ID, and that is using the resource pool is basically just going to set the ID for now. And so then once this sound is actually created, we get the pointer back to it, and then I'm essentially just loading these. And what the load does is that we'll put a load command onto the audio queue, and inside the audio queue, this is where I'm creating the audio sound. So the sound is game side, the audio sound is the AudioEngine side. And so this audio sound is going to add this sound ID, and then it's going to set the pointer. So this audio sound has a pointer to the sound, and the sound has a pointer to the A sound, but inside of the sound object, it's just a void pointer, and we just have to cast it on the audio side when we're doing that. So it's a nice way of kind of hiding that from the game side. And so inside of this add, we're essentially setting this ID, and then this is where we're creating a new source voice. And so in the source voice manager, when we set this sound, this is where we are finding the wave based on that ID that we previously loaded with the file thread, and we pass in that audio sound and have a new callback. So the callback will keep a pointer to the audio sound as well, just so you have access of all the data inside the callbacks. And then this is going to create the X-Audio to source voice based on everything we just did. So that is all this information. So if I go back to here, we're going to load up all these, and all of the functionality of the sounds. If I go back to here, you'll see that these are all set up as commands. So it's a load command, play command, but I also have time events. So instead of play, pan, volume, it's going to be play in so many seconds, load in so many seconds, or milliseconds in this case. So these are all time events that get added to a time event manager, and then that game side in the update loop, that time event manager updates, and then once that is triggered, it's going to pass that back to the audio thread. So everything is basically going through the audio manager's main queue, or the AudioEngine's main queue. So if I go into here, for this first demo, we load up the sounds, and then we're essentially just playing with basic functionality. So we're going to play the same source voice and pan it left and right, and then at given times, we're triggering all these with time events. And so we're also changing the pan, and I actually do that where I spin, if I go to pan command, I actually put the panning and the volume on their own threads. So if we go to execute, so essentially this is going to pan over a given amount of time. And so when I do that, it is going to, from the audio sound, it is going to trigger, I'll go into here, this is where the thread is actually spawned, and it is going to come into here and basically just interpolate over the duration and smoothly pan it over whatever specified amount of time is given. So this is where I set off that panning thread, and I do the same with the volume thread as well, which is right here. And that'll basically just interpolate from the current volume to whatever the target volume is. So if I go back to that and play it, I want to make sure that my window is printing correctly so we can see everything printing out. And you will see here that all of the handles were activated, and then once those queues got, or the commands got processed on the file thread, these are all the sounds that were asynchronously loaded. So now if we go ahead and hit the 1 key, it'll start demo 1. And this is going to print out the current sound being played. So then a little hack I had to include in here is if I press the 8 key, it actually just clears out it basically just removes the sounds that were created in this demo and invalidates those handles. Otherwise we'll fill up the handle manager pretty quickly. So I just press the 8 key, and then we can move on to demo 2. So for demo 2, this is essentially just the Seinfeld demo that we had previously, where we're just appending buffers to a single source voice. So I create a sound that is the first sound in the Seinfeld series, and I load that, and I can attach, for each of these sounds, I have a method to attach a user callback, and I will go into the voice callback for the X-Audio 2 in a moment to show where this is actually triggered. So essentially this is how we'll be notified that the sound has ended, and we can set up whatever functionality we need to do inside of that. So we're basically going to add the data of these sounds. The buffers are going to be appended to this one sound, and then we're going to play that. And so if we go into the actual voice callback, I can show how these buffers are being swapped. So inside of here, what I'm doing is I basically have another circular queue for each voice callback, and these voice callbacks will basically just keep checking if there are any buffers. So I append those all up front, and then it will just run through and pop off the first one and append it, and then the next time that buffer ends, it's going to add it. So I basically have to do this stupid check I had to set this flag to 0 initially because if every single buffer has this flag set, when the first buffer ends, it's going to trigger the on-stream end and it's going to initiate our callback, but we don't want that because we want it to play all of the buffers first. So I had to do this stupid little hack to stop it from, or make sure it's the final buffer. And then we just submit that to the source voice and print it out. And then on stream end, so once the series of buffers is finally depleted and we're done, this is where we, if there is a callback, it'll check this pointer, make sure it's not null, and if we have one, that's when it'll trigger this callback. So this is where we can set it to do, if we want to print, if we want to stop all the sounds on the table, if we want to stop just this sound on the table, that's what we will do. So if I go ahead and play this, make this bigger. The sound names are being printed out at the bottom when the buffers are being swapped. So for the third demo, we're basically using the same sound and the same buffer for each of these sounds, and we load these all up and we attach different callbacks to each of these. So basically this end sound command is going to remove the sound from the table. It's going to stop it. I can go into here and show you exactly what it's doing. End sound command. Essentially what that's going to do is remove the sound from the table. And so what that's going to do is just search the table if the sound pointer is equal to this sound, and then if it's here, if it has not stopped already, it's going to try and stop it again and set that row in the table to null. Basically that'll make it available for next time. So if I go back to the thread. So what's going to happen here is we're basically setting the priority for all these, and then the lowest, well, highest value, but it's the lowest priority item is going to get kicked out for if the table's full. The lowest priority one with that's been playing the longest will get evicted, and then the new sound will be added. So I'm essentially I pass in the priority to each of these play commands. And then for, same thing goes for these time events, where if I want to play this in, 1 second, then I can give it a priority and a duration of when I want this to start playing. And then I'm adding these print commands to essentially print the table at these current, at the current time given, and then we can see the different sounds of the different priorities being removed and added. So if I go ahead and play this. So that last command is basically stopping everything that was playing in the table. That's right here, stop all table command. So it's basically just if anything was still playing that was listed on the table, it's just going to stop them all at that given time. So for the fourth demo, we are again doing these user callbacks, and we're basically just printing the details of the sound playing. So it's going to give us on the when the sound ends, we're basically just going to get a printout of the sound, how long it played for, its ID, its handle, etc. So we can go ahead and play that. So the last and final demo is the delayed file loading. So originally I had this commented out because I did not want to load this up front in the original game loading. And so now we are essentially going to load this at a specified time. So what I'm actually doing is I'm going to be playing these two sounds up front, and then I'm going to trigger this time event that's going to load this command. And once this sound is done loading, I'm appending a callback to it, so it's going to just load and play at the same time. And this was a command that I had to basically just kind of do a one-off play, load and play it quickly at any given moment. So that worked out for this, where it's going to just be, it's going to load this command, and once that's done, it's going to trigger this load and play. And then we're going to stop Beethoven at a given time, which we're essentially manipulating this file that we're delaying the load on. So if I go ahead and put this up. So yeah, so definitely could clean this up a little better. I had the object pooling as well, and so we kind of had to hack that apart to get it to work for all of these demos, and that was not a very clean process. So I definitely know that that could be improved, and I'm sure I'm hopefully not leaking anywhere, but you never know. I'm sure I am at some point, but essentially I just need to clean this up a little more. But this is a good exploration into this. It had a lot of interesting puzzles and was pretty fun to actually figure out, because it's a different experience when you have to listen for the errors rather than seeing the programming errors with your eyes. So